Hey everyone, it's Mr. Canfield. I hope this video finds you well. At the time of filming, it's the week before Thanksgiving or the week before Thanksgiving break. We're getting ready for our quiz. So I'm gonna go over all this stuff, focusing on things that are more important than others. I have my my quiz that I have ready for you pulled up so I can really make sure I emphasize things on here that you would want to know how to do more than something else. So we can start with these first two questions. Honestly, the main idea in triangles is like big angles and big sides go together and little sides have to add up to more than the third side. Because, you know, if we think about it, if we have an 18-inch side, then these two together need to add up to more than 18 inches because they're not just going straight across, they're going up at some, you know, some angle. So since 7 plus 13 is more than 18, we're good. 7 plus 13 is 20. So that means that it's going to be able to reach without having to go straight across. Same idea in this one, right? If this is 13 long, well, if I only have 9 and 4, 9 and 4 are going to meet like that. We're not going to have any space to pop them up at all to make a triangle out of it, because we would need to make, we would need to travel more than 13 to do all that. So since these add up to be exactly 13 and not more than it, this one fails. Honestly, I'm gonna skip number 2. It's 31, but I'm gonna skip it. Number 3, find the measure of angle C. So let's see, it's 150, 155 if we add those up. We know that these two and this together are all 180. So if we do 180 minus 102 minus 53, that'll give us whatever's here. And 155, 25 degrees. So really it's just a subtraction question. So the next thing we could talk about with this, and this is a big hint that I'm dropping out there for you. If we look at these angles, the angles show us the size of the corresponding sides, right? 102 is the biggest angle and it's across from the biggest side. 25 is our smallest angle and it's across from our smallest side. 53 is in the middle and that's the medium size. So that's not a coincidence. It always works like that. So first little hint of the video. I don't know why that guy's hairdo is a check mark. That's weird. I guess check mark hair is kind of a thing, right? Woo! All right. I don't know why I drew the check. Hi, okay. Hi, Mr. Canfield. All right. Two angles in a triangle have equal measures. So this question is, it's a little tricky. If I had given it to you like this, x, and x plus 30, would you be able to solve that? Because you need to be able to for the quiz. And the idea here is this plus this plus this all together is equal to 180. Because that's what the angles in a triangle do. Sorry about that if I am making you tired. I am tired. X, that's 3 of them. So we say 3x plus 30 is equal to 180. We'll subtract the 30 from both sides. 3x is equal to 150. Divide by 3, divide by 3. Good, x is equal to 50. All right. Oh, sorry. So find the measure of the 3 angles. So we have 50 and 50, and then 50 plus 30 is 80. So, and sure enough, 2 angles are equal. The third is 30 larger. Yep. All right. Let's see. This is a good question for us to go through. I'm going to do the proof. I'm not going to use the flow chart because I'm not giving you the flow chart on the quiz. I will 100% give you word bank though. The word bank's not going to be just the words you need. It's going to be all the words that you might want to use. Oh, excuse me. So, if I am trying to show that CDF and EFD are the same, that's going to be like the last thing I write. CDF is congruent to EFD. And one way we could show congruency is to show that all three sides and all three angles in both triangles match up. But we don't usually have enough of that information. So let's see what we do have. We do have two sides that are equal. We got the 1, 2, and the 1, 2. So I can start and I can say, we were given, don't put a comma there, it's not where that goes in the sentence. We were given CF, so CF is right here, which is bam, bam in our labeling. That means that I would want to do bam, bam, ED. Excuse me. We're given this and the CF, ED, CD. And so CD is the first two. That means that we'll use the first two EF for labeling it. So we're given that. And the two acronyms that we have talked about so far are SAS and SSS. So in both of these, we have two sides that are congruent, which is this situation. And the idea is, if I can show that two sides and an angle between them are congruent in both triangles, then everything else follows suit and the whole triangle is congruent. The other one was, if we can show all three sides of both triangles are exactly the same, then all the angles have to match. So we're looking to see if we can get either one of these situations. And this problem has one special thing. It's this right here. Both triangles have this side. So I'm going to put 3 marks on that. Both triangles have this side. They share it. And so what I'm going to do is I'm going to say that DF, so DF is a shared side. So I can say DF is congruent. If I do DF, then I need to make sure I follow, so second, third, FD. So now I'm going to say by, well, let's see, that's side, side, side. 3 sides are congruent. By side, side, side. Box, done. Okay. So the proofs on the quiz are a little bit more because I'm not just necessarily going to give you those congruent things, but we'll see some more that might look like the quiz. All right, on to number 6. So 6 is a similar thing, right? I'm going to end up saying triangle TEK is congruent to triangle TAK. That's going to be the last statement, and we're going to need to figure out one of my acronyms. So I either have to show that all 3 sides and all 3 angles match in both triangles, or I need to show one of my shortcuts. And I see that angle there. I'm going to assume we're probably going to do SAS for this one. So turns out, yeah, they have a side that's equal, they have an angle that's equal, and then they share this side. So that's enough to have 2 sides and the included angle. 2 sides and the included angle. Now I just got to put that in proof words. So let's see, TE, first 2, that's TA. So TE is congruent to TA. That's given. Here's another, instead of writing any sentences, I'm just going to be like, yeah, I got that because it's that. And then let's see. ETK. Nope, that's not a line segment. Angle ETK. So ETK starts in the middle, goes to the left, goes to the end. Middle, left, end. So ATK. Okay, so also given. I don't know why I wrote the word also. I felt like it. You just say this given, this given. You say this, draw a little arrow and say they're both given. That's fine. Lastly, TK, that's first to last, first to, oh, it's same both times. So we could say TK is congruent to TK, and that's that shared side. And the mathematical word for that is the reflexive property. Not reflective, but reflexive. It's the idea that something is itself. But shared side really is plenty for us. And so now I've shown a side, an angle in the middle, and a side. So by SAS, the triangles are congruent. Box. Okay. Number 7. This is a really good question for us. You can expect some some puzzles like this, where you start with some information and you're trying to find something, and there's not a whole lot told to you beyond that. And it's just a matter of hunting down, using things we know, taking next steps. So like I see this 88, maybe I want these other angles over here. Well, if I did that, it would be 92, like 88 minus, or 180 minus 88 gives us 92. 92 minus 180 gives us 80. Oh yeah, those are vertical angles. So of course those are gonna be the same. And here's 92. Like you can just kind of write stuff down. We don't necessarily need all that, but it's true. Like in this one, 113, I know that's 113. I know this is 180 minus 113 is 67. Wow. Let's try writing the number 67 again. So that's 67 and that's 67. Hey, wait a minute. I don't care about any of that stuff up there, but I do care about the X down here. I know this is 88. I know this is 67, 67. There's X. So, hey, check it out. Let's do 180 minus 88 minus 67. Pretty sure it's 25. All right, and I definitely don't have a calculator right in front of me that I could type buttons into. I'm lying, I do. Okay, 8. Excuse me. We can definitely expect a puzzle of this difficulty. So, I've taught this a few times recently, so I hope I'm not glossing over it too easily, but this is 60, 60. Oh, I didn't even read the question. Oh my gosh. If you don't read this question, it's impossible. Triangle GEF and HIJ are equilateral triangles. That means all the sides are equal. Since all the sides are equal, that whole small angle to small side thing still holds true. Since all the angles are the same, the sides all have to be the same. Other way around. Since all the sides are the same, the angles have to be the same. So both these triangles are equilateral. And I want this. I have two out of the, oh, I only have one angle, but I'm looking for that one. So you might go, well, I have this quadrilateral here. If there's something that you can figure out with that, go for it. I don't know what to do with that. But then I looked up here and I saw this triangle. Sorry, I'm not upset. I just got a scratchy throat. Oh, sorry for the noise. Bonus phrase for this quiz. You just write it at the top, and that is, take a cough drop, Mr. Canfield. You just... My name is F-I-E-L-D, C-A-N-F-I-E-L-D. A lot of people mix that up for some reason. It's the word can and then the word field. But yeah, take a cough drop, Mr. Canfield. Just put that at the top of your paper and enjoy a bonus point. So anyway, back to this. We got our 60, we got X. I know this is 53. And we can find this angle right here, because we've got a straight line right there. We've got 68, we've got 60, and that together have to add up to 180. So 68 and 60 together, and then just take them away from 180. You get 52 when you do that. Well, hey, now we've got 2 out of the 3 angles there, so I can do 180 minus 53 minus 52. It's 105. So I got, this is 75. And we can keep chasing the angles, right? 75, that goes to 75 there. And now I've got this triangle with a 75, a 60, and the x. And so when I do 180 minus those two, we get what x is, and it should be 45. Let's do 180 minus 75 minus 60. This is not a joke, by the way. I will give you a bonus point for that. Number 9. 9's worth talking about at least a little bit. We got these two sides with that are congruent. Well, since those two sides are congruent, if I ignore this middle line here, I know that these two angles have to be the same, right? So that's every isosceles triangle. The two sides are congruent to the two angles. Well, hold on. That's 90. This is 90. Both triangles have like this angle and a 90-degree angle. What's that mean about the third one? Well, if you take these away from 180, you'll get some number. If I take these two away from 180, they're the same two numbers, so we'll get the same number here. So this and this are the same angle. And this side here is shared. Let's see, AZJ. And so what we see here is we see a whole bunch of stuff like this. Well, all of a sudden you have two angles that are equal, this line going down the middle, literally the middle, because those have to equal each other. So it has to be the angle bisector of that. There's a few ways we could have talked about it. That's just one of them. 10 is, I don't want to stress anybody out. You don't really need to know how to do 10. It is 15 though if you do it. 11. 11 is also, we don't really need to know how to do it. I'm gonna go over these, and then we have a couple of extra problems I'm gonna throw in, because I'm trying to do that more this year, throw in extra problems that maybe weren't on the review that are need to knows for the test. Okay, so we've got SAS and SSS. It says, okay, so let's, if this was gonna be a quiz question, major difference is it'd be like this. And I'm going to include both word banks on this page. So, let me see if I have another copy. I need to get some WD-40 for this chair. It's the noisiest chair. Okay, so we got all these, and our first proof is asking, given M is the midpoint of HS and GT, prove GMH is congruent to TMS. GMH, TMS, these two triangles are congruent. So if we're given this is the midpoint, well, okay. Well, what does midpoint mean? Midpoint means it cuts a line segment in half. Look at that. So GT gets cut in half perfectly. Oh, so does HS. So the way I would say that in a proof is I would say since M is the midpoint of HS and GT, that's another way of saying given, GM, that's the first two, is congruent to TM and HM, and let's see, HMSM. By definition of midpoint. You could probably even just start with that and ignore the beginning part because the midpoint thing is given. Anyway, the next thing I'm going to show is, I have two sides. I either need to figure out if that angle there is the same or that side there is the same. So I don't see any information about GH and ST. But I do see that we have these crossing lines, which means that this angle and this angle have to be the same. That's called vertical angles. So I would just say angle GMH, that is not the letter M. Let's see if I can make it there. I made it the letter M. GMH, so GMH is just left to right. Okay, so GMH, that's gonna be TMS when I write it on the other one. By vertical angles. Okay, well now I have a side and a side and the angle in between them. So by SAS, you could say the triangles are congruent by SAS. I just am writing it before for some reason today. I did it again. GMH is congruent to triangle TMS. QED, or box, or done. Okay. The last proof is kind of more of the same stuff. Difference about this one is we're given the congruent sides. This time we're given it's the midpoint of GJ, so we can say like those two are the same by definition of midpoint. So I got so I can say I know, let's see, IG is congruent to, let's see, IG is last first, so IJ is given, and GH, first, second, JH is congruent to JH by definition of midpoint. This, I would accept this. This is fine the way it's done. Like shorthanding it. And then we know IH, let's see, that's the last and the second. IH, last and the second. Oh, still IH. IH is congruent to IH, and that's because shared side. Well, that's a side. Congruent sides, congruent sides, congruent sides. So triangle GHI is congruent to triangle JHI by side, side, side. Done. All right. So I know I'm kind of zipping through it. It's okay. I want to do like two more. Let's say we have a 50-degree angle down here, and then 2x plus 10 right here. And I asked you to solve for x. Well, if I was doing that, I wouldn't be able to finish the question. Okay, it's isosceles now. Okay, let's say I give you this question. So try to solve it, see if you can solve for x. I just made these numbers up now, so it could be gross. All right, so if we're gonna try to solve this, well, we have those congruency markings. That means that this and this both have to be 50 because the two congruent legs mean there's two congruent base angles as well. So that's 100 degrees. Oh, that means that this is the rest, right? This is 80 degrees. So I know that 2x